Department of Chemical Engineering, St. Joseph College of Engineering, Chennai. I specially want to welcome our guest as well as our alumni, Mr. Arnachalam Subramanian, working as a process engineer at Fox Factory, Georgia, USA. Our HODs, Dr. R. Bhaskaran sir and Dr. N. Venkatesh sir, my colleagues and participants from various institutions. To start with, anodizing is an electrochemical process that converts the metal surface into decorative, durable, corrosion resistance, and anodic oxide finish. Aluminum is ideally suited to anodizing, although other non-ferrous metals such as magnesium and titanium can be anodized. Anodization is the electrolytic passivation process used to increase the thickness of the natural oxide layer on surface metal surfaces. Aluminum alloys are anodized to increase the corrosion resistance and allows coloring and improved lubrication. Some aluminum aircraft part, architectural material, and consumer parts are also anodized. Anodized aluminum can be found on MP3 players, smartphone, multi-tools, flashlights, cameras, sporting goods, window frames, roofs, etc. Our guest will explain about the process of anodization and purpose of anodization. Now, I will hand over this session to our guest, Mr. Arunachala Subramanian.
Thank you, sir. Hi, everyone. First of all, I want to thank St. Joseph's Chemical Engineering Department for reaching out to me. Secondly, I think this is a really good opportunity for the students to meet with the alumni and also to gain knowledge just by sitting at home. And I'm really glad to be a part of this. I do want to discuss about two things. One is the anodization, which is my work that I'm doing now. Second is I want to just start with how to draft a resume and how to look for jobs and how to pursue or how to apply for masters. Uh, I want to start with this first because I feel after the technical session everyone will be like sleepy and even I'll be sleepy. So it's better that I start this because this is also equally important. Um, yeah. So for first the resume. The resume should be more sweet and short. So I would recommend like had a lot of numbers, say example like cost savings and efficiency. Say if you are doing a project or something, how much improvement is there in the efficiency. So those things would add a lot of advantage to the resume. So basically, the selectors would choose whichever resume is unique. So they want some candidate who are unique. So we have to excel from others. We have to show you have to show that you are different from others. So numbers is the first thing which I found helpful. So that's why I'm saying that. And second, there is an approach called STAR approach: situation, task, action, and results. So whatever experience that we are doing, say if we are working in a working as a chemical engineer or something, first you have to write what does the company does and what are you doing, and even for this applies for even for projects and for internships. The second thing is the task. So what task has been given to you, what project has been given to you, and what work did you do? So all those things can be written. So you can bullet down like 4 points underneath each experience or underneath each projects. So first should be the situation, second should be the task, and third should be the action. So action is like what skills that you implemented in the project, and what did you learn and what did you get out from the project. So that should be the third point, and the fourth should be the results. So how much savings did you do by implementing that project, or how much savings did you do to the company? So these four steps would be really helpful. And then I would recommend also write skills after each projects and experience. So let it be computer science or something, even C++. Those also you can write near the skills. And the keywords from, so when you are applying for Indeed, like in US, there are websites like Indeed and LinkedIn and stuff like that. So in those websites, you will see job postings, and you will also see the responsibilities and duties for those postings. So those will have the keywords. So I would suggest add those keywords to your resume. It should be something that it should be that you have done already, but still you can write those keywords from the job duties, because particularly in US, companies have resume filters. Uh, so when you apply for a position, the resume goes through a filter. So it sees how much it is matching to the responsibilities or the duties that they have posted. So based on that only, you will go to the next step. So I would suggest add those keywords. And next thing is, you can also add independent coursework. So say if you learn something on your own, it's an added advantage because it says that you are a self learner. So whatever that stuff that you learned on your own, you can add it as a section called independent coursework, and you add them because that's, like I said, it's an advantage. And after framing your resume, give the resume to at least 2 3 people to proofread them, um, because you might not see something which the other people might see. So do proofread. And say if you are applying for 3 different positions, say like a chemical engineer or a process engineer or a data analyst, whatever it is, I would recommend have a separate resume for each position. um, Even when I was applying, I had 3 different resumes. So uh, that would be more specific to the position that you're applying. So that's an important thing. And for searching for a job, when you are going for an interview, um, prepare like 100 situations that you have already done, like 100 situations that you overcome in your projects or internships and jobs. And uh, say that when you so try to tell that as an answer when someone is asking the question in an interview. So first you have to start with what situation was it, and what task did you do, and what skills did you learn, and what was the result of it. So just don't say that you participated in the symposium, or you organized this one, you learned this one. It should not be like that. It should be like a complete package. Like it should start with the situation till the results. So that will show that you are confident about what you are saying, and that will help you to crack the interview. And second thing is prerequisites and skills development. So if you are aspiring to be in one position, say if you want to be a process engineer, there will be certain prerequisites for that job. So try to go through the job postings before applying, and try to develop those skills. So those skills, um, you cannot learn those. I mean, some you could learn from the books, but some you have to learn it by yourself. And for that, that should be a start. Like looking through the job prerequisites is a start. And third thing is, you have to contact a lot of seniors, maybe seniors or managers, hiring manager or HRs. And this is particularly useful when you are in other countries, as well as it's useful in India, but still it's more useful in US, because the hiring people will know that you really want to get into this job, and that you are passionate about that job. So that is a really important thing. I'll go to the next slide. Pursuing masters. So what do you have to do to apply for a master's degree? So three points are more important. First point is the industrial experience. So say if you are graduating from St. Joseph's with a chemical engineering degree, you wouldn't be having a industrial experience, but still I would suggest go for more industrial visits, or go for more internships. Try to do some projects in industry. So those things would be really helpful, because a lot of university, even though if you have a lesser GPA, or even though if you have a lesser GRE score, that thing is the industrial experience is more important, because you are coming here to gain more industrial experience, right? So that is the first thing. And second thing, letter of recommendation, LOR, and statement of purpose, so SOP. So those two things are more important. LOR is you have to get the recommendation from your professors or from the managers to whom you worked for. So that is the LOR, and SOP is statement of purpose. So you have to write an essay saying why do you want to get into the course, or how would you be benefiting to the university, or what skills that you have to implement in that degree. So those that SOP is really important. I would say like 30% of your application depends on SOP. So that also you have to proofread, and I can help you if you want me to. Like I have my LinkedIn page link over at the top, so please feel free to contact me anytime. I'm really glad to help. The third thing is GRE, TOEFL, and CGPA. So this I would say maybe like 20 to 30% of your application depends on it. So GRE, particularly the math score, is really important. So you should get at least one above 160 out of 170. So that is really important. And what do you do when you have to select a university? So three things are really important. First is the location. Um, you do want to study in an area where there are a lot of opportunities. Say if you are studying in a place which is rural and there are no opportunities, then you won't you would be it would be difficult to get a job, because the lot of companies here in US or UK, they tend to hire local candidates. So the location is really important. I would suggest you can look into California or Texas, or tri-state area like New Jersey, New York, Connecticut. So those areas are really good for industry wise, and also education wise. The second thing is the research areas. So when you're applying for chemical engineering master's degree, go through the website, university website, and see what research areas they are specialized in. Say if you want to do something related to energy, you have to look for university that has energy, that does energy research, because the opportunities and as well as the syllabus that they uh, have depends on their research areas. So that is really important. And the third thing is ranking. So ranking, I mean, if you are into any of the 100 universities or 200 top 200 universities in US, that's fine. It doesn't matter that much, but still ranking matters. And apart from chemical engineering, what courses? Say if you're not interested in chemical engineering, and if you want to try something else, you could look into MS Industrial Engineering, MS Data Analytics, MS Engineering Management. So engineering management is kind of like both MBA as well as engineering, and you can look into MBA Business Administration. Uh, so all the four courses have good opportunities. Industrial engineering have more better opportunity than any other courses, because chemical engineering, I mean, everything is, I mean, one thing is not won't be a cup of tea for one guy, right? So you have to try something. So if you feel like you want to try something, these courses that you can look into. Okay, now I'll jump into anodizing. So to give a small intro about me, I graduated from St. Joseph's with chemical engineering degree by 2016. I did masters after that, and I have 2 years of experience in this field, anodizing. Let me jump into these slides. So, what is your role as a chemical engineer in an anodizing line? This is not something like a very big chemical industry where you have like boilers or cooling towers or chillers. This is a very simple line. So, as a chemical engineer, you will be more involved in process improvement. You will be implementing manufacturing techniques like Six Sigma or Lean. Say, like there are many techniques like Six Sigma techniques, Kaizen techniques, or 5S principles, or umbrella Lean concepts. So a lot of things you have to learn. This I would say. I mean, it's better if you learn on your own. So go into websites like Udemy or edX, or any other websites where you can learn these principles. This will be helpful in any manufacturing industry, in any chemical engineering industry. So the say Six Sigma, you can also do certificates like Six Sigma Green Belt and Black Belt. That will be really helpful when you are applying for jobs. The third thing is in the anodizing line, there will be a lot of chemistry. So the chemical engineer would be dealing with a lot of chemistries and the dyes. That will be colors and dyes and seals. So they'll be dealing with all those things. And also they have to maintain the tank parameters under certain control limits. Um, so you would be implementing your statistical skills like statistical tools, SPCs, statistical process control charts, everything to monitor the parameters within proper limits. Um, and another thing that chemical engineering would do is they would write the process steps for each jobs. So the anodizing industry is basically two types. One is the job shop, and another is manufacturing industry. So one is a job shop is they just do anodizing. So they get jobs from any industry like aerospace or defense or food industry or any industry, but they just do anodizing. So that is called a job shop. And the second is the manufacturing industry. What they do is they manufacture one particular product, but from the scratch, from the raw aluminum. They do everything from the raw aluminum till finishing and assembling. So I work in the manufacturing industry. My company manufactures suspension shocks and other parts for race cars and cars, automobile industry, stuff like that. So what the chemical engineering would do is for each of these different jobs, they would have to write the process steps. So which step it has to follow, how much, what should be the immersion time, what should be the current that you have to supply. So all these things the chemical engineer would do. And also you would have to maintain scrubbers, chillers, rectifiers, all the other equipment in the line. And one another thing what he would also do is wastewater treatment. Of course you are dealing with a lot of chemistries, a lot of solutions. There will be you would be having a wastewater treatment system in the anodizing line. So there will be equalization, neutralization tanks and chillers and sorry uh, clarifiers and settlers and stuff like that. So you'll also be dealing with all those stuff. And then the quality control. So you would be getting a lot of different problems. Sometimes you won't know what's the root cause of the problem. So you would have to investigate everything, and you have to do a lot of process control tests and quality control, because that's really important. Particularly in US, we follow a lot of standards, quality standards, and a lot of guidelines, and you have to make sure that everything is as per the standard. The next thing is the safety. So the safety, yes, a lot of toxic. You deal with a lot of toxic chemicals. A lot of safety incidents could happen. Even while the operators or the racking people, when they rack the parts, um, they get into a lot of incidents. So safety is really important, and particularly, and a chemical engineer would be involved in that. So aluminum. So what are the properties or what are the benefits of aluminum? So aluminum is the second most abundant metallic element in Earth, and it is widely used in a lot of manufacturing fields. I didn't know that before getting into this field. I didn't know that aluminum is used widely. Only after getting into the field, I got to know that everything almost in your house or in college, most of the things that you see is made up of aluminum, and most of them are anodized. So it is, yeah, after iron, it is the most widely used engineering metal because it is lighter and it has a lot of good properties like high electrical connectivity, high thermal connectivity, and also the tensile strength is low, so that you can easily do a lot of engineering designs. You could roll them into sheets, or you can stretch them easily. So that's why it has good ductility and good malleability. Um, yeah. So what are the alloys of aluminum? So aluminum starts with 1000 series till 7000 series. So each series is just the additional alloying element that you add to the aluminum. So the the 1000 series, you it's just the aluminum. The second series you add copper. The 3000 series you add manganese. 4000 series you add silicon. And each is important in one particular way. Say for example, the 2000 series and 7000 series, where you add the copper and the zinc, they'll be more corrosion resistant. So people who want a corrosion resistant aluminum, they would use these alloys. And 6000 series, so that has more conductivity, electrical and thermal conductivity. So lot of automobile industries and lot of electrical industries, they use the 6000 series because of this particular benefit. So among all these alloys, uh, in an anodizing line, you will see mostly 6000 series and 2000 series and little bit of 5000 and 7000 series. 5000 series will be like more shinier than any other series, but most widely used is the 6000 series. So there are types like 6061 alloy, 6063 alloy. So there are a lot of types in those. And some are heat among all these alloys. Some are heat treatable and some are non-heat treatable. So what is heat treatable? Heat treatable is a manufacturing technique where you can apply adverse heating conditions. You can apply like more colder condition or more hot conditions, uh, which in which it would change the chemical properties of the aluminum itself. So that changing the chemical properties would be advantage for some industry. So that's why they do heat treatable, and some are non-heat treatable. So what are the types of aluminum metal finishing? There are a lot of types. Um, the most important one is the anodizing and the bright dipping because it's more widely used. In even in US, a lot of in almost all the states there are a lot of anodizers who are also job shops and who are also manufacturing industries. So they do a lot of anodizing. I'm going to explain more about anodizing and bright dipping in this lecture. And the third one is the aluminum plating. So they also do some plating like zinc plating or nickel plating or chromic plating. So zinc they do for more corrosion resistance. Chromic plating, there are types like hexavalent chromium or trivalent chromium. They also do that for certain applications. Pre-treatment. So pre-treatment, what is a pre-treatment? Pre-treatment is just polishing or giving a sandblast finish or um, grain finish to aluminum. So it's just a very small industry, but it's pre-treatment. You have to do this for applying any type of coating, even for anodizing. You have to do pre-treatment. And the next one is the laser graphic printing. So some even the panel like aluminum, you would have seen a lot of aluminum panels. So what they do is they take a graphic image and they try to import that image onto the aluminum panel. So that is a very new technology, laser graphic printing, which a lot of people they follow now. I mean, instead of visiting cards, you can have an aluminum panel with your name and your degree on it. So that's the laser graphic printing. And the last two things, almost everyone knows about them. It's the paint, like normal house paint, which has volatile organic compounds, which is not so good for the environment. But even they paint on some of the aluminum. Even they do powder coating. So powder coating, a lot of car, like the automobile industry, when you would have seen in a lot of movies or series, or when they try to change the color of the car, they do the powder coating. So the powder coating is also one type which is more common, and it does not have any volatile organic compounds. Okay, I'll now discuss more about the anodized aluminum. So, what are the applications? Where do we see these anodized aluminum? Like I said, anodized aluminum is used in a lot of industries, like in automotive industry, be it a race car or powered vehicles like desert bikes or ATVs or stuff like that, or cars like those. You can see a lot of aluminum parts. And it's really cool when you see these parts, when you assemble it all together, and when you see the final product, it's actually really cool to check it out. The race car, so even the suspension shocks, the suspension and the gear box, and the car body, the wheel trims. So these are anodized aluminums. And also you will see in a lot of in aerospace industry, like companies like Lockheed Martin, Boeing. So these big industry, they have a lot of anodizing lines with big tanks, so that they can anodize the um, aerospace parts. And also in defense industry, like guns and bullet casings, um, even fake guns, the guns that they use in movies and series, like the Deadpool movie. You would have watched the Deadpool movie, the Deadpool sword. So that's anodized aluminum. So a lot of guns and bullet casings are made up of aluminum, and they get anodized. And it's also used in space, like the NASA. They use it in NASA for aircraft handrails, handrails where the astronauts they hold onto it and they walk. So that's also made up of aluminum, and those are anodized too. And the next application is um, construction, the architecture. So a lot of aluminum panels and very big aluminum sheets are used in construction. So those are anodized too, and they get a really hard coat because it has to withstand extreme environmental conditions, right? Like it has to be really corrosion resistant, and it has to withstand all the other extreme conditions. So that's why it get anodized, and they typically do hard coat because hard coat is nothing but you put more coating on it. So when you do that, it will be more. It can withstand more adverse conditions. And the next thing is food industry, like the pans and thermo flask. So those are aluminum, anodized aluminums. And even in electronic industries, like the PCB circuit boards, or the Apple company, they might also have a lot of anodizing line. Even the iPads and the iPhones that you see, the color that you see is basically an anodized color. So, like I said, it's widely used, and a lot of chemical. They want really a lot of chemical engineers also, because this is always this is not a fluctuating field. It's always there, and it will be used everywhere. So they tend to hire a lot of chemical engineers. Um, yeah. So the hardness scale. When you have an anodized coating, so the aluminum oxide that you see here, the one that is circled, so that's the aluminum oxide. That's the anodized coating, and that's harder next to the diamond. So diamond is the most hardest, right? So after that, anodized aluminum is can be that harder, and it's even harder than glass or the steel files or any other thing. So this is why most of the people, they tend to do anodized coating. And what is anodizing? Um, Basically, anodizing is an electropassivation process where you apply electric current, um, and the part that you want to get anodized will be the anode, and you'll be also having the cathode. And a natural aluminum oxide will get deposited on the anode, which is the anodized coating. So the aluminum oxide, the Al2O3 oxide layer over the parts, uh, is what is called as the anodized coating. Um, so yeah, you should have an electrolyte. The electrolyte typically will be like an acid electrolyte, and you would also have to supply electric current. And the cathodes are also aluminum, um, but it will be like a high electrical conductive aluminum, because it has to conduct the electric current. So it will be 6000 series, and it will also be aluminum. So what happens is, when you supply the electric current, the from the electrolyte, the hydrogen ions move towards the cathode, and the oxide ions move towards the anode. So that's why the oxide layer develops over the anode, and that forms the coating. I'll explain more about what are the process steps, and how what are the things, issues that you will be seeing in an anodizing line, and what are the quality checks that you have to do. So all these things I'll discuss in the upcoming slides. So anodic coating properties. So after anodization, what properties do you get? You get a lot of good properties, like abrasion resistance. So like I said, it has a lot of hardness. Abrasion is nothing but hardness. So after diamond, it is the next harder coating. So um, yeah, for construction, in construction industry, they use the hard coat aluminum to withstand any extreme conditions. So that's why abrasion is really important. And corrosion is also important. There's a second thing that you get from anodized coating is the corrosion resistance. Typically, aluminum itself has a very good corrosion property, but even by applying more coating to it, you also increase the corrosion resistance. And so that even say take a defense industry. So the military or the cops, they would be working in very different conditions where they'll see a lot of sea water or salt water, so stuff like that. So it has to withstand a lot of corrosion. So anodic coating provides that advantage. The third one is thermal resistance. It's also it can handle really good temperature. Even the aluminum will melt before the coating. So the thermal resistance is for the coating is more. And the next thing is electrical resistance. Aluminum itself has a very good electrical conductivity. By applying more coating to it, you also increase the electrical resistance. And the final is the porous layers. Um, so coating, yeah, I mean, you can get a lot of properties, but regarding the cosmetic side of it, you would need some colors. Say if you're doing a job for an automobile industry, the color is really important because the cars should be in colors, right? So that's why you also do anodized coating, because in anodized coating also you can apply the colors and you can get any shades of color and any different color, because the anodic coating that you develop after the electrochemical process has many pores in it, like pores where the dyes can get into, and it will add the color to the coating. So that's why the anodic coating is a porous layer where it can give many colors. So I'll also explain more about this in the next slides. I'll open this video. So this is a particular process, anodizing process. So you can see the aluminum. So those sheets are so those rods are the aluminum, which is going first into the cleaning. So you have to do cleaning before giving the coating. So it's going to the degreasing stage and it's going to the rinsing stage. So after cleaning, you have to like rinse them to make sure that you are not pulling out any chemicals from the first tank throughout the line. So after cleaning, you will be doing rinsing, and after rinsing, so yeah, you can see they are doing like three rinse tanks, and after rinsing, they are doing etching. So etching is the second step, which removes the um, top layer. So top layer might have some corrosion or some defects, so that will be removed through the etching. And even after etching, you have to do a rinsing. So it goes into the aluminum parts goes into the rinsing, um, and then it's going into the anodizing tank. So this is where you apply the electric current. You will have an electrolyte, and so you can see the parts that's going in is actually the anode, and it's connecting to the electric circuit. And so those things that's highlighted, the negative symbol. So those are the cathode, and the anode is the positive sign. So after applying some electric current and after staying there for some time, the coating will be developing. So you'll see how the coating develops. So the hydrogen ions, it goes towards the cathode, and the oxide ions goes towards the anode. And so that's why these ions come from the electrolyte, and that's why you get a oxide layer over the anode, that is over the aluminum parts, and that's why you get the anodized coating. Yeah, you can see the barrier layer. So every metal has a barrier layer. So you have to enter that barrier layer to create some changes to that metal. So when you apply the electric current, it forms the pores in the barrier layer first, and then the pores enlarge. So you can see the origin of the pores in the barrier layer. And when the current flows, the pore size will increase. So when you apply more current for at least some time, the pore size will increase. Yeah, here you can see that the pore size is increasing. Yeah, the anodized pores are typically in a hexagon structure, which has pores in it, and only these pores can I mean, when you apply dyes, right, the dyes goes into these pores. So more thicker or more bigger the pore is, more darker the color would be. So here you can see each pore is equidistant from each. So that's why you get a uniform coating throughout. And after anodizing, now they are doing again rinsing, because rinsing is really important, because you have to remove all the chemical solution from the previous tank, because you don't want to pull contaminants throughout the line. So then you have to do the rinsing. Um, yeah, now after the rinsing, you'll be doing dyeing. So the dyeing, the dyes get into the pores. Like you can see the dyes getting into the pores, um, and that adds the color to the aluminum. Yeah, you can get variety of colors, like different shades of colors, based on the dyes that you are using. And the dyeing can be two types. One is electrocoloring and coloring by dipping. So either you can dip the aluminum in a chemical solution, in a dye solution, and the dyes will enter the pores. You can do that, or you can also do electrocoloring. So electrocoloring is basically the solution. It's also like another electrochemical process, where you apply electric current. The electrolyte will be a tin liquid. So when the tin liquid gets into these pores, it adds natural color to the coating. So the color could vary from brown to gray or to black, but you cannot get different shades of colors. It's very limited. But that's also another technique. So after this, what they do is they would do sealing. So the pores are there. You fill the pores with the dyes, but you have to seal them, right? Otherwise, the dyes will come out. So after this enters into the sealing. So you can see the aluminum changed its color after getting out from the dye tanks. So it got the color. Now it will go into the seal tanks, and you'll seal all the pores so that the dyes doesn't come out. Okay, so I'll go back to the presentation. I hope you saw the video. I mean, while presenting, it will be very slow, but the link is here. You can go check it out later. So this is the process. So the process starts from aluminum, the raw aluminum, and then you degrease them. You degrease them, so meaning you will clean them. So it will remove all the oils or any buffing compounds that you used while manufacturing the aluminum. So all those things will be removed, and then you do the etching. So etching is basically you remove the top layer of the aluminum so that it's ready for the coating. So it removes any natural oxide layers or any corrosion or anything that shouldn't be there. So that will be removed in the etching process, and then it gets into the desmutting. So desmutting is like a touch up process. So you do that after etching, because you don't want any etch solution to get into the anodizing tank. So the desmutting will remove all the etch solution, and it will also do a little bit of etch work. So all the degreasing, the cleaning, etching, and the desmutting is considered as the pre-treatment side. So that is the thing that you do before anodizing. And you could also add another thing called chemical polishing. That's where the bright dip gets involved. So the bright dip, you can give a polished color by doing the step. You can so that's in the pre-treatment side, which you do to get a brighter color. So after all this process, you do the anodizing. Like I said, there will be electrolyte, electric current. You supply the electric current. The coating will be developed. The coating will be a porous layer, um, where you can see many pores, um, through which the dyes enter. The dyes gives the color to the aluminum coating as well as the aluminum part, and then it has to be sealed. So you can see the dyeing, there are two types: electrolytic coloring and the dyeing. So typically most of the anodizers, they do just the dyeing because they can get different shades of color. So the dyeing is most widely used in electrolytic coloring. And then after electrolytic coloring, you do the sealing. So the sealing could also be like a electrolytic process, or it can be just like a chemical, where the chemicals will enter the pores, and then you seal the pores. And after all this, that's when you get the finished product with the color, with a added color, and with added thickness, added chemical properties like corrosion resistance and abrasion resistance. And all the finished products, you would have to dry them. So it will go through a drying process, just like a smaller bigger dryer depending on the part size, and then it will be finished. So yeah, so the aluminum, in an anodizing line, there will be racks. So the racks, you have to rack the parts onto the racks, and the racks will be carried through each tanks. So there will be a number of parts in one particular load. So like in the video you would have seen a lot of aluminum rods. It's just not one thing. So we'll have a lot of parts anodized together. So that's an important thing to know, because I'm going to talk about racking next. So um, the racking, it provides a secure connection. I mean, the racking should provide contact to the aluminum, right? So the aluminum, I mean, the electric current should flow from the circuit through the racks, and it has to apply to the parts. So racking is really important. And typically, on the right side, you can see the pictures, how, so you can see the a big bar that carries a lot of aluminums. So these aluminum parts will be put in a racking frame, and each frame will have a spline, and stuff like that. So that's the racking. And you have to, this is really important for giving a uniform current throughout the parts. Now the frames and splines. So the splines are made up of titanium or aluminum, or it could be even a hybrid of both. So the titanium is really expensive, but it lasts for at least 30 or 40 years. And aluminum is cheaper, but it has a very short life. Because the aluminum disintegrates inside the chemical solution. So a lot of people, they tend to use the titanium racks. So on the right side, you can see the picture where you're putting a aluminum part onto the racks. And the attachments. So attachment will be, I mean, attachment is basically the one that connects the racks to the parts. So it can be welded. The parts can be welded to the frames, or it can be connected with the wires, or you can hang it on a plastic clamp. It can be anything. So these are the racking methods. And the cleaner. So like I said, the cleaner, you'll be using a acid cleaner or an alkaline cleaner. What it does is it will have surfactants. So surfactant is basically, it reduces the surface tension of water, and it removes the oils or any grease or any stuff on the parts. And it also has emulsifiers, which make sure that the liquids are mixed together properly. And it will also have chelators and other stuff, which is really important for cleaning all the all the all the impurities. And it should be operated under certain temperature, and the immersion time should also be like 5 to 15 minutes, so that it removes all the impurities. And you can see the list of impurities that I have mentioned here, like machine lubricants or fingerprints, corrosion pits, or any inks, or anything that shouldn't be there will be removed in this process. So this forms a water break-free surface. So on the left, so you can see the picture where you can see the water droplets, which is not broken. I mean, if it is properly cleaned, right, the water surface won't be broken. It will be, you can see the water droplets on the aluminum. So that's when you know that it is cleaned properly. The second step is the etching and desmut. Um, so the Yeah, so the etching is the step that you do after cleaning. You remove the top to remove any surface irregularities or any dye marks or any impurities or any natural. I mean, the natural oxide will be developed, so that will also be removed through the etching process. And say if you produce an coating part, right, you can again put it in the etch. You can strip them and then you can rework them again. So that's a so this is a really important thing to know. And there are two types of etch. One is the caustic etch and one is the acid etch. The caustic etches sodium hydroxide. It's more alkaline. It's widely used. And even you add some additives to remove the sludge from the etch tanks. So the caustic etch is the first thing, and the second thing is the acid etch, which is not widely used um, because it has fluoride in it. The racks are titanium, right? So the titanium doesn't go well with the fluorides. So the acid etch, it's not. That's the reason it's not widely used, but it provides a brighter and matte finish. And the third step is the deox or the desmut tanks, which is the step after the etching, which you do to neutralize the alkalinity. Basically, the etch is a caustic etch, right? So it will be higher pH, and you have to lower it down. The pH has to be lowered, so you will neutralize them in the desmut tanks. And it's basically a mixture of just the sulfuric acid and nitric acid and ion chemistry, which so basically it's an acid chemistry after an alkaline chemistry. And also you have to maintain certain control parameters like temperature or fluorides and the concentration of the acid or the caustic. And these tanks, you don't have to dump them. I mean, you don't have to dump the solution from the tanks even after like 20 or 30 years, because it is a regenerating tank. It will be always operational. You just have to add some stuffs to make sure that it's working properly. Yeah, the rinsing is the most important thing. It will There will be rinse tanks after each pre-treatment tanks, because you have to make sure that the chemical solution is not transferring from one tank to the another. So you have to have a rinse tanks which will eliminate all the chemical solution from the previous tank, and it will make sure that nothing is going on from that step. Yeah, and for the pre-treatment side, we typically use city water, and after anodization, the rinse tanks has to be more pure to remove all the chemicals. And there will be at least two rinse tanks, counterflowing rinse tanks. So from one rinse tank, the flow will be to the another rinse tank. So there will be counter rinse tanks after each step. Yeah, anodizing. The anodizing are three types. The first type is you use a chromic acid electrolyte. The second step is you use a sulfuric acid electrolyte. Third is also a sulfuric acid electrolyte, but it's a hard coating. It's in electronics and stuff like that because it has very less thickness. That is zero point 0.1 mils or 0.0001. A smaller the coating will be. And the type sulfuric acid electrolyte, which is the more widely used type, and the thickness is a medium thickness coating, and for extreme environmental conditions. Yeah, anodizing tanks. So like I explained before, you need electricity, you need electrolyte, you need anodes and cathodes. 6061 and 6063 aluminum, because those are the most widely used because they have good electrical conductivity property. And all the parts will be carried in a manual hoist. So the hoist will be could be either auto or manual. So you can just sit at one place and do everything. So that's hot auto. Or there will be operators who do from who put the hoist from one tank to another. So there are two types. And yeah, the current has to be supplied through rectifiers. It will be either supplied through amperage or it will be supplied through voltage. And the current density is really important. So the anodic coating, right? How will you calculate? Uh, How will you calculate that you will get this much amount of thickness, or you would have to supply this much amount of current? So that all depends on a formula, which depends on the current density and the coating thickness. So the current density, it varies from 9 amps per square foot to 24 amps per square foot, and the amount that you supply, the electric current that you supply, depends on the square footage of the part. So if it's a very big part, you'll be supplying a very big you'll be supplying a lot of electric current. So that's a really important thing to know. And also there will be other parameters like temperature, concentration, which you have to maintain. And the chillers will be used because the temperature has to be maintained in a certain range, like 68 to 72 degree Fahrenheit for type 2. So for that, you'll be using a chiller. And there will be also agitator to mix the solution in an electric tank. um, yeah, all the parameters like temperature, aluminum concentration, acid concentration should be controlled. Yeah, the after the anodizing, in the finishing step, we have the dyeing. And dyes, the anodized coating is a porous coating. The dyes will enter into these pores, and that's when you get the colors. So and they also the dyes can also fade after some time. So it depends on the quality of the dye. If you use a very good quality of a dye, the light fastness, they call it as the light fastness, that is the ability to not fade soon. So that will be based on the dye quality. And you can see those step after the anodizing step. And some dyes are metallized. They have heavy metals like chromium, um, which helps, but it's not environmentally good. So there are some dyes like metal free dyes too. And pH buffers would be added to this the solution to maintain the pH properly. And the next step is the sealing process. So after the dyeing, it goes into the seal tanks, where you have a nickel acetate chemistry or dichromic chemistry, where it blocks the pores completely, so that it doesn't so that the dye doesn't come out soon. And also the sealing is done to physical properties of the coating. So it improves the corrosion resistance, improve the light fastness, to reduce the handling and all those things. Yeah, the sealing is typically used for. I mean, it's avoided in hardcore applications, because in some cases when you apply the sealing, right, it reduces the abrasion resistance. So it reduces the hardness of the aluminum coating itself. So the pores, when the pores are open, it's more hard coating. So in that cases, they avoid the sealing. And you can skip the dyeing step also. You can after the anodizing, you can just directly do the sealing. So you don't get the different colors. So that is the dyeing and the sealing part. And also in the dye and seal tanks, you'll have to maintain a lot of parameters like stainless, or and DI or RO water is recommended after the dyeing tanks. And you'll have a agitator to mix the solutions, and the tanks are made up of stainless steels. So these are the different things that we have to understand for the dyeing and sealing. And then after this, the parts are dried, and then it enters into the assembly section. Yeah, the bright dip. So the bright dip, we do this to get a brighter color. So what it is the bright dip. So the solution is a mixture of phosphoric acid, nitric acid, and copper. So the phosphoric acid and nitric acid, what it does is it removes the top layer of the aluminum, and it makes sure that the copper is entering into the aluminum surface. So the copper, what it does is it adds brightness to the parts. So this brighter part will be this step is done the pretreatment side, and then we do anodization later, and then we supply and then we apply the dye, and then we seal them. So the bright up is just the polishing step that you do in the pretreatment. Yeah, what are the common issues that you see in an anodized coating? We could see a lot of pits on certain parts when you try to use the rinse tanks with a lot of chlorides or something like that. Like you should make sure that the chloride content is within limits, so that you don't get pits. And also the alloys like 2000 and 7000 series, you get a lot of pits because they have zinc in them, and that doesn't go well with the tank solution. So in that case you will get pits. So how will you overcome this? So you have to maintain the parameters under certain conditions. And for 2000 and 7000 series, you will be using a sacrificial metal along with the parts. So along with the parts, you'll also put a metal, which will be typically magnesium. So what the magnesium does is it acts as a shield for the for the parts. So it will get affected, but it won't allow the parts to get affected. So that is one thing. And also you see die bleeding. So the bleeding after, like the second part, you can see after the from the holes to the structure. So that is the die bleeding. So that happens if the rinsing is not proper, and if the solution gets into the holes or the small crevices that you see, and if it doesn't come out until the die tank, the die starts to bleed, and you can see stuff like that. And bare spots are typically kind of like pits, where you won't see where the spots where there won't be any coating. So that also happens. And burnt parts. So when you try to apply more electric current, some parts would be like burnt, and you cannot use them at all. So that happens. And streaks is also like the die bleeding. You can see them even after bride dip. It happens because of the gases in the bride dip. So when the nitric acid fumes. So I forgot to say this point in the bride dip section. I mean, the bride dip is really toxic. I mean, it's very difficult to handle because it has stronger acids, and it produces toxic fumes. So these fumes, what it does is it creates streaks over the parts if it's not properly handled. So that is one another issue that you see. And improper color. So when you put the anodized part in a dye tank for a longer time, or something like that, or if the concentration of the dye is not proper, you get improper colors. So that also has to be monitored properly. And uneven coating thickness. So this happens when the part is not properly fitted into the racks. So when there is no proper contact between the racks to the parts, we get uneven coating thickness. Yeah, quality control. So how do you control all this? So the quality standards, we in US we follow a lot of standards like the military standard or ISO standard. NatCap. So NatCap is particularly used in defense and aerospace industries, and the ASTM, so American standards. So in one line, you'd have to make sure that you are following 2 or 3 different standards, and one standard will say one thing and the other standard will say one thing. So it's really difficult to maintain everything, but you have to do it because the customers won't accept the parts if it's not in certain quality. So what tests that you do? So we do corrosion resistance tests. So that you do with a salt spray chamber. The chamber will uh, apply some salt over the parts and see if you are getting pits. If you're getting pits, it's a failure. If you're not getting pits under certain time conditions, then it's more corrosion resistant. Similarly, you do for abrasion. So the first picture that you see below, the bigger picture with a hood, with a triangle hood. So that's the salt spray chamber. The next thing, which is like a record player, right? The record player kind of equipment. So that's the abrasion tester. So that tests the hardness of the aluminum panels or aluminum parts. And the third for coating thickness, there are instruments which uses a eddy current principle. So it applies magnetic induction through the parts, and based on that, you could say, okay, this part is this much thicker, or something like. You can monitor the coating thickness. You can check if the coating thickness is within the range by using these equipment. And the light fastness. So this is basically for the dice. So you have to make sure that the dice the color is okay for particular time. Like it shouldn't fade after some time. So it undergoes the UV chambers. So you'll put the parts in the UV chamber and see, and you'll apply the UV light and see if it's fading sooner, or is it fading after some time. So that's the one thing. And the sealing also, there is a type called dye stain test. You apply some stains over the parts and see if the stain is still there in the part, or if it's not there, then it's properly sealed. So that is one another thing. And dye color measurement. So on the left side, the big graph that you see, that's a color axis. So typically in any color industry, they'll call it as a LAB value. So the LAB value is basically, the L is the lighter value, and A is green to red value, and B is blue to yellow value. So based on the value, you basically you are just giving a number to a color. So based on that, you can make sure that the color is within a certain number, is within a certain range. So that you do with a spectrophotometer. So even the dye solution, you can put it in the spectrophotometer and see if it's in the proper color range. And even the parts you can check with portable spectrophotometers if it's in a certain color range. Yeah, the quality control. The another most important thing is the statistical process control charts for each parameter, like temperature or concentration. You have to make sure that it's in proper limits. So this is a tool that you would have learned in chemical engineering degree, but still it will be more advantage if you learn it on your own. So you will have the upper control limit and lower control limit, and the darker area near the center. So that's the 1 sigma zone. Typically, what people will try to do is they will try to maintain their parameters inside that 1 sigma zone, so that there are no big variations. Because if there are a lot of variations, right, you won't get the process is not linear. You will get a lot of problems. So it's better to have a linear process. So, and any point that is above the 2 sigma zone, or closer to the, or above the 3 sigma zone, that's called a defect. So when something happens, you go back into the chart and see, okay, on that day I'm seeing a point above the 3 sigma line. So that's a defect. So that's how you know that you are seeing a defect, or a defect is going to come. So this is really important. Yeah, I think I've covered all the at least most important areas that I could cover. If there are any questions, please let me know now. Hello? Okay, I see a lot of questions on the side. Question from Chidambaram: is aluminum better than titanium? Which would be best for heat exchangers? Um, Yeah, I mean, for this process, I would say titanium is better, because the rack should be titanium, because the aluminum will disintegrate in in the chemical solution. But for heat exchangers, I think aluminum is better, but I'm not sure about that. Yeah, what is the lifetime of anodized material? It can stay. It depends on the thickness of the coating. If the coating is more thicker, then it can stay for a longer time. Otherwise, if it's very thinner coating, it won't last that much. Can anodization completely hide scratches and dents? Yes, it can hide. It can hide if you tend to give a proper coating. You can hide the. I don't think it will hide a dent, but it will definitely hide scratches and fingerprints or anything like that. Is hard anodization safe? Yeah, the hard anodization is safe. It's not difficult compared to bright dip. It's very safe. It's you're just giving more current, It's nothing. There are no environmental factors that affects the durabilities of anodized materials or anything.
So the next question is, what is the what are the advantages of nickel seal over hot water?
Sorry.
What are the advantages of nickel seal over hot water?
Okay. So the seal. So basically, when the sealing is typically done to increase the properties, right? The corrosion resistance or something. So depending on the type of seal that we are using, the corrosion resistance would vary. And also when you try to put more dyes onto the pores, the sealing should be proper. So if you use a colder temperature seals, the dyes won't come out soon. So in that case it's used. And hot water is only used when you don't want any chemistry to get into the pores. So that's used when in food industries, so you don't want any chemistry to be on your pan or something, so in that case it's used.
The next question is from Nalita. So what happens if the current supply exceeds a certain limit while anodizing?
The current supply is what? Sorry.
The current supply, if it exceeds a certain limit while anodizing.
Yeah, so in that case, uh, I mean, basically, what we do is we set we would say the control system to stop when it reaches a certain current. But in case if it exceeds the certain current, right, it will burn the parts. So you don't have to. You should not put more current on the parts. Otherwise, it will burn the parts and you won't be able to use the parts.
The next question is from Mr. Prem Kumar. Is anodizing and electroplating same?
Is anodizing and electroplating
Same.
thing? Yeah, it's an passivation process. Like it's an electroplating thing. You have the anode and coating, and then anode and cathode, and you try to apply electric current, and the oxide layer will develop. So it's an electroplating process.
What are the other materials preferred for anodization other than aluminum?
What are the other materials that you try to anodize?
Which are most preferred for anodization other than aluminum?
Yeah, other than aluminum, we can use like even zinc plating is also good. They do, but aluminum is widely used because it's the engineering design. I mean, you can make any kind of uh, formation from the aluminum metal, so that's why it's widely used. But after that, zinc, um, even titanium gets anodized. So a lot of other anodized are also there, but mostly widely anodizers they just do the aluminum.
The next question is, aluminum gets aluminum oxide coating naturally when it is left out in the atmosphere. What are the advantages of getting coated in electrochemical cell?
Sorry, can you repeat that question again?
Aluminum gets aluminum oxide coating naturally when it is left out in the atmosphere. What are the
Hmm.
advantages of getting coated in electrochemical cell?
Okay, so yeah, the aluminum natural layer that forms over the aluminum won't be thicker. I mean, won't be having that much properties. Uh, Basically, we do the anodization just to get the properties and to get different colors, right? So you would have to do the dyeing process, and everything can be done only with the electrochemical cell. So the natural oxide layer that forms on the aluminum, after some time you'll see the corrosion. But when you try to put more coating on it, the corrosion won't be you won't see the corrosion pits soon.
The next question is from Mr. Rajaraja Cholan. Since you are saying plenty of acids for the processing, whether it can be recycled and used.
It cannot. I mean, the acids cannot be recycled because it will have a lot of contaminants. And for in US, like there are a lot of environmental regulations. Like you can just do whatever that's possible. So what we do is we send them to the waste treatment plant, and whatever that's recyclable will be used. But there is nothing that you could recycle. Only the RO water or water that could be recycled. Everything else would be treated and would be sent down to a sewer or would be made into a filter sludge. Yeah.
The next question is from Nalita. If welding is done while removing some rating, will it be damaging?
No, it wouldn't be damaged. So what they do is the welding will be done only for very big rods, so which they cannot fit into a frame or something like that, and which is really difficult to carry or something. So it's very not it's not commonly used. But what they do is what they weld it and they will cover it with certain other stuff over the welded parts. So the welding will be there if you just see a single part, but it will be covered with all the other parts.
So the next question is, what material precautions should be taken before anodizing?
Yeah, material precaution. Once we get a raw aluminum part, right, you have to go through all the parts and see if there are any corrosion already before, because if a part has stayed outside for a long time, there will be corrosion itself, and you cannot give proper coating over the corrosion. So you have to inspect them, and you have to check if there are any fingerprints or very big scratches, because those cannot be hidden with a coating. It will be visible even after applying more dyes. So that the material inspection is really important. We do that before anodizing.
The next question is from Mr. Paul. If in case defects of color variation arises within the same batches of electrolytes, what will be the best troubleshooting method in anodizing field without affecting the productivity?
Yeah. So what we do is, if the color is improper, right? What we do is we strip the coating by sending the parts to the etch tank. So by putting the parts in the etch tank, the coating will be stripped, and then you can again apply the coating, and again you can get the color. So that is the most common step that you will be doing when you don't get the proper color. But after certain, like, you can do maybe like 2 or 3 reworks, but after the third rework, it will be very dull and it won't be. You just have to discard the part.
The next question is also from the same participant. What is the rate of defect pieces produced per day of production?
It varies a lot. It depends on how much the production capacity is. Say if you are running like 40 different jobs a day, you'll see everyone will be like rushing and you'll get a lot of defects in that case. But if it's like very slow day, and you won't get that much defect. And whatever the defect, we try to encounter them, and we can rework, because there are a lot of loopholes that you can do to avoid those defects. You can do reworks, um, or you can do other process steps which will cover those defects. So there are things which you could do.
The next question is from Mr. Venkatesh. How are the byproducts handled or reused?
Byproduct after what? I think he might be asking after the wastewater treatment, maybe. So the byproduct, what we do is, so the wastewater treatment, the byproduct, we we'll try to treat everything, and the byproduct will also be entering through the clarifiers and settlers, and it will be turned into a sludge. So the whatever the heavy metals or anything that's coming out from the wastewater would be turned to a sludge and would be sent to the fertilizer or something like that.
Thank you so much, sir, for answering all the queries.
Okay, thank you, Arunachalam, for your valuable time. I would like to express our sincere thanks to our guest, Mr. Arunachalam Subramanian, for sharing his valuable ideas about anodization in this International Alumni Workshop series. I would also like to thank our beloved HODs for their moral support and guidance. I'm very happy to express my vote of thanks to all our staff members for their valuable suggestions, and participants who have made this webinar a great success. Thank you. Thank you all.